From numerous investigations on charged objects, Coulomb, a French scientist in the 1700s, found that his data of the forces between two charged balls fit this equation here, where Q1 is the charge on the first ball, Q2 is the charge on the second ball, and R is the distance between the center of the two balls. Epsilon 0 is a constant called the permittivity of free space, and in SI units, its value is 8.85 times 10 to the minus 12. This means that the magnitude of the force on each charge is proportional to the product of both charges and is inversely proportional to the distance between them squared. The factor of proportionality is 1 over 4 pi epsilon 0. A positive force points directly away from the other object, while a negative one points towards it. What does Coulomb's law tell us? It says that if you charge either ball up, the force will increase, which makes sense. Also, Coulomb's law accounts for the fact that both positive charges and negative charges will repel each other, since the force is proportional to the product of the charges. A positive number multiplied by another positive number is always positive, and a negative number multiplied by another negative number is also always positive, because minus 1 times minus 1 is 1. Since both these interactions give positive values of the force, which means that the force is pointing away from the other object, this will give a repulsive force. On the other hand, a negative charge and a positive charge will attract, since a negative number times a positive number is always negative. So the force points towards the other charged object, attracting it towards it. Coulomb's law also tells us that if you move the balls further away, R will increase, and thus the force will decrease. This makes sense too, because we know from experience that charged things don't exert much force on each other when they are far away, but when you bring them closer together, they will exert a much stronger force on each other. Coulomb's law states that the exact way the force depends on the distance is 1 over r squared. As you can see, the value of 1 over r squared rises sharply near r equals to 0, and is quite small further away. Next, we will see how to apply Coulomb's law.